Okay, so we've discussed data types and how we can make our own data frame using two series we built inside of our notebook. Here I am back in our notebook. Let's assume no time has passed and we've loaded up our virtual environment. We've remembered to do all that. And you can see actually my terminal is here running away. Okay, so let's go ahead and figure out how we can import some data. So on the class website, I have a bunch of data up there, different types. You'll notice one of the types is called carsales.cs or car-sales.csv. And what I've done is made a data folder inside my machine learning folder, and I've downloaded that CSV to that file there. So you can see here's my pandas notebook, here's data, here's the CSV. That'll be important because we're about to import that data. We need to know where it is, okay? So if you want to import data to your Jupyter notebook, what you can do to make a data frame by importing data is let's say we're going to call this car sales. And when we're working in Python, as opposed to a lot of other languages, we're going to use something called snake case where you do this underscores in between. And we're going to make a data frame. So we're going to ask pandas. Remember, PD is how we ask pandas to do things. We're going to say, pandas, go ahead and read a CSV for me. And then you want to pass it the file name of your CSV. In our case, it's data car-sales.csv. And it has to be passed as a string. Okay, notice I'm passing the file name there as a string. If I hit Shift Enter, theoretically the data frame car sales gets made, and we can double check that by Shift Entering on car sales, and there we've got this data frame from the data that was inside that file. Now this is fake data, right? It's not important. It's very small. We won't be dealing with data this small most of the time. It's made up, right? So just keep that in mind, but it'll be a helpful example for us as we learn how to do some things with our data. Number one, I want to point some things out. I want to point out that this is what we call structured data, right? We mentioned this before, but structured data is in a table of some sort. It looks like a Excel spreadsheet, okay? So this is structured data. And with that structured data, we can use pandas to actually get us some information about that data. So we can start analyzing our data a little bit. One thing you're going to find important is what types are these data? Is this data? So what we can do is we can do car sales dot d types. And what it's going to tell us is what kind of types we're dealing with here. Notice that the make is an object. Okay, that's anything it doesn't really know how to classify as a basic number. So object is going to be our generic in this case, right? It's an object of some sort. Color is an object of some sort. Int 64, it means this is a number. This is a 64-bit number. Doors is a 64-bit number. Price is an object of some sort. Now that's interesting. When we look at price, it doesn't look like an object, it looks like a number. So why isn't a number? Well, this $sign and this comma kind of change it from being a number into being an object. So if we're going to want to work with this, that's something to keep in mind, because if we all of a sudden, well, I'll show you in a bit. So let's go ahead and let's do some others. We can actually use car sales. Let's get some more information. We'll use the function describe. Okay. And we get some information. We get how many there are of each odometer and doors. There's 10, which you'll see because it's numbered from 0 to 9. So there are 10. We get the mean of each one of these. We get the standard deviation, the minimum, the 25 percentile, the 50 percentile mark, the 75 percentile mark, and the max of each of them. And it doesn't mean they line up. I mean, you'll notice the max on the odometer is here on number 4, but the max on doors is here at number 3, right? So it's not saying these are the same object. They're just telling you information about each one of these columns. Notice again, price is not here, right? Price is not here. It's only taking the ones that are labeled as int 64. Those are the only ones it's considering when it's going through the describe method. Only number ones, right? Number ones. Okay, let's go for another one that we can use to look at our data frame, which is the info function. And we get this. We get a count of each column. We get what type it is. We get how many of them. We get the fact that none of them are null, right? That's interesting. That's an important thing. So why are we using this? Why do we ever use these? Well, you're like, I can look at 10 things and I can see what data is missing. I could probably even run a count and a sum and a mean all in my head. Maybe, okay, sure. But like I said before, this is fake data. 9 is nothing. There are data sets that will have 80,000 that you might be working with. You can't possibly look at 80,000 entries. That'd be ridiculous. So we use functions like dtypes, describe, info to get information about our whole data set that then we can address and use. And we'll talk more about why we would address them and use them, but it allows us to start sort of messing with our data without having to look at every single one. We can also do car sales.sum. We can do car sales.mean. I forgot. I didn't spell car sales properly. I forgot my underscore. Okay. Because it's not all numeric, it's not going to do a mean for us. So we can't actually do car sales mean. We can only do car sales mean on certain columns, on certain series, right? Each column is a series. We can only do car sales.mean. You could imagine though, if I had some series like 50, 39, 40, and I made this, hold on, let me make this a pd.series. I could then call the mean on it, and you get the idea. Take the average, okay? It'll also do that for columns if we separate out the columns. I want to look at the sums result, though, quickly, because it did do sums, even though they're not all numeric, and you'll notice how it kind of did it. It would do what we call concatenate, right? It kind of pushed together all of the strings, and it added together all the numerals. Again, notice price is not added together so much as concatenated, treating it kind of like strings. Mean takes the average. Okay. So those are a couple of good ways of dealing with the data inside and getting information about the data inside. We might also want to get information about, believe it or not, you're going to come across instances where you're not even going to be able to see all of the columns in one place. So if you want to, you can do this, which will give you all of the columns that our data frame has. We can also do this, which is kind of cool if you're ever in that position where you really can't see all the columns. If you do .t, this is going to transpose, so the columns end up becoming your rows, and your rows end up becoming your columns. Okay, that's another nifty trick for kind of rearranging the data and giving us another way of looking at it. We can also do car sales dot index, and it tells us the range of our indices, right? It starts at 0, it stops at 10, and it goes up by 1. And it's talking about these values here. These are the index. And these were not in our CSV. If we look at our CSV in a spreadsheet program, those numbers were not in there. Those numbers, those indexes are created when you create the data frame, okay? Those are created as part of, so believe it or not, if we were to export this and include the indices in the export and then re-import it, it would give us another set of indices. Not great. And there are going to be times where this happens where we have to sort of like manipulate this data frame into that data frame, export, and then you're going to have to remove the indices when we do that. So that's something to keep in mind. Indices can kind of mess us up there a little bit. We can also see how many things are in our car sales data frame by doing a simple length, like any Python. In other languages, we've used .count or .length. In Python, you use this len function that gives you the length of a data type. So length of our car sales data frame is 10. We know that now. There are 10. Okay. You can also look at certain portions of your data frame because often you're going to be looking at so many, they don't all fit on the screen. So we can also do car sales dot head, which will give us just the first 4 or first 5. Car sales dot tail, which will give us the last 5. So those are good ways of doing it. If you want to get at, and by the way, you can change that. If you don't want the first 5, let's say you only want the first 2 or the last 7, you just put whatever number you want in there and it will give you those from those. So there's 7 of them. There's the first 2. There's the last 7. Okay. You can do that with head too. That'll sort of specify how many you want of each. Okay, so we can also sort of locate individual pieces. So if we do, let's see if we can do this. Car sales. I want to dot locate 3. And that's going to give me the third item in the third object, the third row, all the information about it in my data frame. So that's using the dot loc. You can also locate things other than, so that located the index, but what if I did car sales dot locate and I passed it something that wasn't just like a number? What if I passed it white? Or let's pass it blue. The question on the table is, can we get something other than just the index? No. Okay. So it's not going to search through the data frame to find something. It's only going to identify things that are at that particular location 3. Good. Okay. What about if we wanted to get let's see, what if we wanted to get car sales dot ilocale 3. We're actually getting the same thing with ilocale as we get with locale. So the big difference here is locale is going to get you the third thing, whereas ilocale is going to get you the index 3. So that's kind of an important difference, or vice versa, right? Locale is going to give you the index, so whatever is indexed at 3, ilocale is going to give you whatever the third thing is. So if this got shuffled, I wonder, actually, do we have a shuffle? Let's give this a try. Let's do... No. I think we have to bring in the random library to do that. Okay. But if it got shuffled, basically, you could see that locale is always going to go to number 3. ilocale is always going to go to the third object. So that's important to note, the difference there. You can also locate more than one thing. So you could do car sales, and you could pass it a range into really ilocale or locale. Let's do ilocale. And let's get everything. And this is how ranges work in Python. So if I did 0:1 car sales, I'm going to get just one object, but it's a range. Shouldn't it give me 1 and at least the next one? Well, in ranges in Python, 1 is excluded. So the first number is included in the range, but it's kind of like everything from 0 to less than 1, right? That's kind of how this range is built. So if I wanted the first 2, I would actually need to do 0, 2. So it would give me 0, 1, but not 2, because 2 is not included. It's exclusive. It's inclusive of the first value and exclusive of the second value. If I wanted all the ones up to 2, I could just do :2. If I wanted all the ones after 2, I could do 2:, and then it doesn't care how many there are. It's going to do all of them. If I wanted every other one, I could do : 2. And what that's going to say is I'm not interested in where you start at the beginning. I'm not interested in where you end at the end, but I do want you to go for every 2. And there it gives me 0, 2, 4, 6, and 8. So it goes starting value, inclusive starting value, excluded ending value, and how steps you want to take. You can also go from the end of a collection in Python by using a negative number, and there it's going to give me 9, 8, 7, 6, 5, 4, 3, 2, and 1. And then, by the way, if I did dot I locale, and I passed it 3 now, I wonder what it's going to spit out. Let's see. Now it spits out the Honda. Why? Because I reversed my list using the iLocale, and then I put the third item. Not the thing indexed at 3, but the third item. If I take this out, it's going to go back to BMW, because even though I reversed my list, BMW is still indexed at 3. It's all the way down here, but it's indexed at 3. And iLocale is going to give me the third item in the list, which when we saw, when I didn't do this, right, we saw that it's reversed, so the third item is this Honda. Okay. All right, good. Okay, and then if you want to select an individual column, we can do that by just passing in the column name in block here, and just make sure you spell it right. So for instance, if I want the make of the car, there's the column, the make of the car. I could do, right, we talked about this before, if I wanted to get the mean of the doors, for instance, I can do that there now. Okay, the mean of the doors is 4. So because that is a series, essentially, all numerical. Odometer KM is kind of a weird name, but you have to spell out the whole thing with the spaces and everything. So odometer space KM. You have to spell out all of that to get that information. Okay, so it's important that the name match exactly. You can also do filtering when you do this. So let's say we didn't want all of the car sales. We just wanted the car sales that were above a certain, where for this one, they were above a certain thing. So let's say we wanted car sales. And we're going to pass it car sales where the odometer is above 100,000. This little statement here is filtering now. It's saying, okay, get me the car sales, but only where the odometer is above 100,000, and it's only going to give you 2 cars, right? So this is a really nifty way of filtering your data and kind of looking at parts of your data based on what is true. We could also do car sales. Let's do color, which in this data set is spelled with the British color. And we're going to say equal white. Let's see what we get. Nothing. Why don't we get anything? Well, because I spelled it with a lowercase. So let's make sure that this is oh, that's wrong. I forgot. It's supposed to be this. There we go. Okay. And let's do dot lower. Oh. Series has no. I guess because it's being based on a series. Okay, so let's go ahead and do white there. And then we get it. I want to look that up quickly while I have you here. So if you ever get stuck on anything, this is normal Python, so you can just look in the Python documentation. And if you want to check out how to make things look, dot lower is built in for string handling. That's interesting. So it was not interested in doing it, I think, particularly because it was on a data frame series, but it looks like We might be able to do it here if we do .str.lower. Let's give that a shot. Okay. And then if we take this out, beautiful. Okay. So as long as we take it, turn it into a string, each one into a string, make them all lowercase, then we don't have to worry about case, because sometimes in your data frame, data is not clean, and that's an important concept to get across in this class. Data is human-made often. Even if it's really machine-made, the humans told the machine how to make the data, right? Which means it's often full of wonky things like weird capitalization, missing information, lots and lots of stuff like that. So anytime you can come in and sort of make it so that it's less failable, right? It's more likely to catch all the things. Maybe at some point white got typed in all caps. Who knows, right? It's better in this way. And then if we find areas where that's true, if we were looking down this list and we're like, oh, that's weird, this one is typed in all caps, you can then go through and fix that so that when you're doing your machine learning, it's not caught off guard by sometimes white, treating white in all caps different from white not in all caps. Okay. So that's good to know too. Okay, and then one last thing I want to show you or two last things I want to show you. I want to show you how to do a crosstab, which is an interesting way of sort of analyzing the data. So we can do Pandas has a crosstab function, and in a crosstab, what essentially you're doing is comparing two features, if you will, in your data to each other and kind of seeing how they interact. Car sales, and we're gonna do let's do the make, and let's do car sales. We'll do the doors. Did that backwards. All right. And there we have a comparison, right? One BMW has 5 doors. All the Hondas, all the BMWs, all the Hondas have 4 doors. There's 3 of them. All the Nissans have 4 doors. There's 2 of them. A Toyota has 3 doors, and 3 Toyotas have 4 doors. So you can kind of see a quick comparison of 2 features of the data against each other and get more information about kind of what's going on here. Obviously a lot of 4 doors, and many makes don't have variations on the doors in our particular data set, right? You can start getting some information. Finally, the last thing I want to do is I want to show you group by, because I've used this one a lot when I'm trying to do some data analysis. Maybe I want to see what's true about all of the same make. So I do car sales.group by. I pass it the column I want to group by. So in this case, I want to group by make. And you can actually group by more than one column, although it starts to get a little bit confusing if you do that. But then you have to tell it, okay, if you want me to group these together, how do I combine the data to show in a group, right? If I'm going to make all the Hondas the same, how do I combine the data? And a good way when you're dealing with numerical data is to do .mean. That didn't like that. Why did that not like that? What did I do wrong? Car sales dot group by. Okay, so grouper. Let's see what I did wrong here. Even though some of the other columns don't have numbers, this should still be okay with me grouping the ones that do have numbers and just making those a group. Car sales dot group by. So generally when you get these errors, sometimes the most informative piece is write down could not convert black to numeric. Okay, so it is trying to group by All right, let's try. What does this do? Okay, so that doesn't do it. What if we do... okay. We'll do this sum for now. In the past, I want to say that pandas would just ignore columns it couldn't do by mean and just show you the mean. So they may have changed that. So we'll do sum because we know it's actually okay with sum. It can just concatenate the strings. And then here we see all the BMWs, which there was only ever one. All the Hondas, though, are now grouped together. All the Nissans are grouped together. And all the Toyotas are grouped together. I'm interested in when we do group by from now on, and I'll look into this, how it's going to want us to sort out which ones we're going to group by and which ones we're not. But that's for next time. So great job today. Some ways for us to start looking at our data. I want you to go ahead and go through this and just practice importing your data, looking at it, looking through the data, running some of these functions on your data to kind of get a feel for how are we going to understand our data frames when we import them. All right, good job.